Hello everybody, it is Ethan here and welcome back to another video. Today we're going to do a deep dive into one of the more prolific tornado outbreaks in the state of Missouri, and this took place back on March the 12th, 2006. And in terms of tornado count, this was one of the most tornadoes Missouri has ever received in a 24-hour period. And I want to do a meteorological breakdown on this severe weather event because I am from Missouri and I find this event quite fascinating because widespread tornado outbreaks like this are not very common, at least in the state of Missouri, but the perimeter space in this particular setup was quite uncharacteristic. So, without further ado, let's jump into the breakdown. To start, here are the official storm reports from the SPC for this day, and on the bottom left you can see that there were nearly 150 tornado reports, with nearly all the reports occurring in the state of Missouri, with an exception for a few reports in Illinois and some scattered reports along the eastern border of Oklahoma. The large swath of the tornado reports in red takes up basically the entire state, and with that said, you can also see this was a big hail day, mainly occurring in the early life cycle of the outbreak and consolidated to the north and west of the tornado reports in green. In terms of the actual number of surveyed tornadoes that touched down on the ground and did damage, there were a total of 58 tornadoes, which resulted in numerous injuries and associated fatalities, making this a deadly outbreak. The strongest tornado was rated EF4, occurring just northeast of Columbia, Missouri. It touched down southeast of Madison County around 9:45 p.m. CST, tracking nearly 30 miles east and demolishing multiple homes, leveling a few, and eventually lifting in Monroe City at around 10:20 p.m. It had a max width of 500 yards, and despite the extent of the damage, there were no injuries or fatalities reported. Real quickly before we dive into the meteorology, here is the day one convective outlook issued by the Storm Prediction Center, which highlights a high risk level 5 out of 5 for severe weather and a corridor from southeast Kansas basically through two-thirds of Missouri, extreme southeast Iowa, and west central Illinois. Hazards did include the threat for strong to violent tornadoes, with a 30% hatched area outlined in the same corridor, with a large 10 and 15% surrounding that. Additionally, damaging winds were a primary threat, although not forecasted to be significant, expected mainly in the 45% region. And lastly, very large to giant hail was forecasted along a large, widespread swath, coincident with the 45% hatched area across a large portion of the central United States. All in all, a very prolific outbreak of severe weather was forecasted, and it ended up being a very well forecasted event from the Storm Prediction Center. To give some background before we jump in, this event had three different rounds of supercells, with increasing intensity in each round. So we're going to try and identify all the mechanisms going into each round and dive into those details to come up with why this day was such a prolific day. So to begin, we're going to analyze the overall large-scale synoptic pattern, and we'll be using the RAP reanalysis data from the Storm Prediction Center's Mesoanalysis Archive, and start at 500 millibars. I think we can all tell here that there's a highly amplified trough situated across the western half of the US and with its neutral tilt to slightly negative tilt, and then a speed max rounding the base of the trough. Notice the subtle perturbation in the flow northeast of Arizona into northeastern New Mexico. This is a shortwave of focus for convective initiation in the open warm sector later this evening, and this shortwave is also reinforcing lee cyclogenesis across the southern high plains, which we will investigate more soon. Notice how much of the central United States is mainly in this broad fetch of southwesterly flow, and so we're going to have to rely on little kinks embedded within the flow to get these in rounds to really get going across the day. Moving forward 3 hours here to 15Z, notice off to the west we see the shortwave embedded within the flow has become a lot more defined across the Four Corners region. Additionally, we can see this convectively enhanced shortwave across Missouri, coincident with the first round of severe weather. With that said, most of the storms were elevated, which means they were not rooted near the ground and mainly produced the large hail. Let's move forward 3 more hours to 18Z. From here, I want you to notice the height falls that occur over time through 0Z. Pay attention to this region circled in red and notice the degree of height falls as the axis of the shortwave approaches from the west. Pretty substantial, right? Since height falls induce surface pressure falls, this would also support the strengthening and deepening of the surface cyclone over time. And so we have a pretty large scale mass response occurring across much of the region, especially across Missouri. Going through time to 9Z time frame, the mid-level trough starts rapidly pivoting northeastward and takes on more of a negative tilt as the speed max overspreads the western side of Missouri. Notice the enhanced isotax across northwest Missouri here in yellow. With that said, the degree of forcing is quite strong with this setup, becoming more enhanced with time. Moving down to 700 millibars now, this level will give us a better idea of those smaller scale short waves we attempted to annotate at 500 millibars. And these are going to act as the little engines to get these little rounds going throughout the day. To start, we'll look at 15Z, or around 10 a.m., and notice a reflection of the shortwave trough aloft translating across Missouri. Again, this was the precursor to the first round of convective activity. Going forward to 18Z, when we get our second, more robust round of the event, this is around 18Z once again, and we see a subtle shortwave, not very defined, but a subtle speed max and a subtle perturbation in the flow across Kansas and Oklahoma, and this is the precursor to the second round of more enhanced convective activity. Again, now going forward in time to 0Z, this is again now another shortwave trough, and it's positioned across Kansas and Missouri border, and it has much stronger flow on the order of about 50 knots, and this is coincident with the perturbation. So this is the main forcing mechanism that initiates the most robust storms of the event. Now down to 850 millibars. At 15Z, there's a cyclone deepening over the central high plains of Colorado, and by this time, gradients in the open warm sector are quite weak, pending the influence from the synoptic wave aloft. So 850 millibar flow is relatively weak on the order of 25 to 30 knots, mainly in that southern Missouri corridor southward. Also notice the stout thermal gradient across Kansas, Nebraska, Iowa, and northern Missouri. This is an area of strong warm air advection, coincident with elevated convection early in the life cycle of the outbreak. Again, mainly those hailstorms that we talked about. Jumping straight to 0Z now, just as storms are initiating, the approach of the synoptic wave aloft reinforces the 850 millibar cyclone to deepen and move eastward, yielding a substantial increase in gradients across the open warm sector. As a result, 850 millibar flow increases to magnitudes to the order of 40 to 45 knots, which is much more conducive for strong low-level shear. By 3Z, we see the same trend with continued deepening of the cyclone at 850 millibars and enhancement of the flow in the open warm sector to 55 and even 60 knots, and then eventually by 6Z to 70 plus knots. So it's quite obvious this is a strongly sheared environment favorable for tornadic supercells. Jumping down to the surface in the early morning hours at 12Z, we notice the surface low is initially deepening over the southern high plains in northeastern New Mexico, and you can see the cyclonic circulation or counterclockwise circulation around the center of low pressure. Off to the east, we have a warm front stretching east-northeastward through portions of Oklahoma, Texas, and southern Missouri. Up to the north, we have an occluding low in Canada with an associated cold front draping to the south. Notice how much of Missouri is still relegated to the north of the warm front, and so we're still pending the northward advance of that warm sector to the south. South of that front, we see strong southerly winds originating out of the Gulf, pending strong moisture advection into the central United States. Looking at raw surface data now, still in the early morning hours, to look at some of the moisture profiles. Again, we have that surface low deepening in northeastern New Mexico with that warm front stretching east-northeastward. And notice to the south we have a large swath of low to mid 60s dew points and along the Red River into portions of Oklahoma, Arkansas, and even a little bit into deep southeastern Missouri. Up to the north, again same time, temperatures and dew points are quite meager, sitting in the 30s, 40s, and low 50s. So not anything supportive of severe storms, and mainly going to be those elevated storms that we talked about in the early morning hours, manifesting north of that warm front. Continuing on into the early afternoon hours, this is 18Z, and the surface low has advanced northeastward, and the warm front is now positioned across central Missouri northeastward. Notice also across central Kansas we have a dry line that's mixed eastward, and we can see that the winds to the west are much more westerly and much more southerly to the east side of that dry line. Ahead of the dry line in the open warm sector, we have dew points now in the low to mid 60s across much of Missouri, stretching all the way up into the I-70 corridor. To the north of that boundary, we're still sitting pretty low in those dew points, and so anything north of that boundary would likely be elevated. Pushing to 21Z here, this is just a little bit before the most robust round is about to initiate off of the dry line. I want you to notice the distinct dry line bulge situated across east central Kansas. Look how convergent the dry line is coincident with that bulge. Just to the west of that boundary, we have very west-southwesterly winds, and then just to the east, it's very east-southeasterly and is very favorable on a storm scale to initiate convection. But why exactly is the dry line bulging? Well, if we look in the mid-levels of the atmosphere at this time, also at 21Z, we see a mid-level jet coincident with that dry line bulge, and that's effectively advancing the dry line eastward and initiating convection by strengthening that convergence zone. Going forward to 0Z, the surface low continues to deepen, and by this point, the cyclone is at max amplification and we are ready to go. Winds in the open warm sector are strong and out of the south, and as we move to 3Z, they back out of the southeast and strengthen, and so we continue to increase that low level shear wind profile due to that wind field of the surface. And the reason for the backing winds in the open warm sector is due to the deepening of that surface low. And so the timing of all these features was very favorable to elicit this sort of outbreak. Continuing to 6Z, we still see the same idea with that dry line mixing eastward, and now we see the cold front advancing from the northwest. So anything initiating off of that would be linear in nature by this point, but also just notice how expansive the warm sector is. We have a large swath of 60s dew points, strong south-southeasterly winds, and so again, we have a very favorable parameter space throughout time that's allowing all these supercells to take advantage of this environment. Alright, so now we're going to look at all the tornadic supercell ingredients, and that's going to include strong buoyancy, minimal stable air, strong deep layers, vertical wind shear, streamwise vorticity, and low cloud bases. So if you're not aware of those ingredients, those are the typical significant tornado ingredients, and we're going to look at each of these to try and get an idea of the parameter space. Starting with the buoyancy, we're going to look at the mixed layer cape and SIN. And so we're going to get an idea of how unstable the atmosphere was. So at around 21Z here, we have a large swath of 2,000 joules per kilogram of mixed layer cape and a corridor just ahead of the dry line and along the warm front in Missouri, southeastern Kansas, and much of eastern Oklahoma. Also very uncapped, and so by this point we would expect robust storms once they are able to initiate along with that synoptic wave. Going forward in time 3 hours to 0Z, we see again that mixed layer cape still maintaining itself across a large swath of the region, still about 2,000 joules per kilogram through much of Arkansas, Oklahoma, Missouri, and even a little bit into the Ohio River Valley. Now for our second parameter, we're going to look at the effective bulk wind difference. And so we really want to see for supercell storm mode a very strong effective bulk wind difference. And so this is just how strong our winds are changing with height in a deep layer. And so we can see that we are changing by a factor of 70 knots through the effective inflow layer here. And so very strong deep layer shear supportive of supercells across a large swath of the region. And if we overlay our warm sector here at 21Z and compare the orientation of these shear vectors with respect to the initiating boundary, i.e. the dry line, we can see that they are very much perpendicular to that boundary. So any storms that do initiate, in this case supercells, they will be able to move off of the zone of ascent and be able to stay discrete as individual cells. And this would be very favorable for tornadic supercells, especially considering the low-level shear profile. Speaking of low-level shear, let's look at the effective storm level felicity to give us an idea of how streamwise the vorticity is in the low levels of the atmosphere. Come 21Z, we see about 200 meters squared per second squared of effective storm relative felicity in a corridor from southern Missouri southwestward into Oklahoma, with a little bullseye of 300 meters squared per second squared in eastern Oklahoma. Going forward to 23Z, we see a major increase, especially in that central Missouri corridor, of 500 meter square per second squared of effective storm low felicity. And so a very strongly sheared environment in co-location with a very buoyant atmosphere and a supercell environment. And so something that would be concerning a meteorologist on this day for sure. It's just that the environment and the parameter space is very uncharacteristic, especially the widespread nature as it is in Missouri. And going throughout time, it continues to increase into 3Z, seeing bullseyes of 600 meters squared per second squared. And so a very strongly sheared environment and a widespread tornadic supercell seem likely at this point. Again, our another ingredient that we need to look for is low cloud bases, and so we're going to look for our lifted condensation level height. And we can see at 0Z just a large swath of low cloud bases on the order of 700 meters up to 1,000 meters. And so anything less than about 1,200 meters, and uh, you're going to have a significant tornado environment as long as you have the other parameters aligned with that. And so we have all the parameters to support a significant tornado environment, so let's put all those together. And this is the significant tornado parameter, valid for 0Z, and that's just putting all of those parameters that we just looked at all together into one parameter. And you can see that it's maximizing right across that central Missouri corridor, basically along I-70. And so a very, very potent environment across a widespread region of the central United States. So now we're going to look at some environmental distributions based on some climatology in central Missouri. And so I just want to use this to demonstrate how uncharacteristic this environment really was. And so if you look at the box and whisker plots oriented horizontally in red, those are the mean values for each of the parameters across 104 cases. And so if we compare the parameter space to the mean values across these cases, first let's look at the mixed layer CAPE. And so you can see in that red bar that I highlighted across mixed layer CAPE there, we're sitting on the upper end there, about the 75th percentile at the 2,000 joules per kilogram mark. Going to the effective bulk wind difference, we can see we're above the 90th percentile, sitting there at about 70 knots. The effective storm level felicity sitting at about 500 meters squared per second squared, and that's again on the upper end of the threshold. Down in mixed layer LCL, we want less, and we can see that we are on the lower end of that threshold. And that's yielding an STP way above any STP values that are characteristic for central Missouri. You can see that we are skewed way off to the right of that box and whisker plot. And so again, a very uncharacteristic environment, which made sense to why we got such a widespread outbreak of tornadoes. So let's look at some observed soundings or thermodynamic diagrams here. And this was an observed sounding in central Oklahoma as of 12Z or 7 a.m. Central Daylight Time. And you can see a pretty buoyant atmosphere here already, and a sign of the elevated mix layer here in the mid-levels of the atmosphere. It's those warm, dry air that emanates from the desert southwest and gets advected east atop the moist layer. And you can see the steep lapse rates just really carving out that mid-level layer and allowing instability to build. And that's what's going to get advected northeastward into Missouri later on. And you can also see down at the surface we have a shallow but moist boundary layer, and that's also going to continue to get advected northeastward. Notice by this point we have mixed layer CAPE values in excess of 3,000 joules per kilogram, 0 to 6 kilometer shear vectors in excess of 65 knots, and 0 to 3 kilometer storm low felicity values over 350 meters squared per second squared. So already a pretty potent environment to the southwest. Now let's go to 0Z when the main round is getting going here. And we can now see this is in Springfield, so southwest Missouri. And we can see here that we already have an uncapped, extremely buoyant atmosphere with a deep moist layer and the boundary layer. And again, 2,300 joules per kilogram of mixed layer CAPE, so very buoyant. Deep layer shear in excess of 60 knots, so more than capable of producing supercells and over 240 meters squared per second squared of 0 to 3 kilometers storm low felicity. And so a pretty favorable environment for tornadic supercells. But let's diagnose this photograph a little more deeply. So this vector here that I just annotated in red is the storm motion for a right-moving supercell in this environment. And we'll just annotate that in a red dot there. And I just want to annotate just how streamwise the vorticity is. So we talked about how storm low felicity is a proxy for streamwise vorticity, but we can actually estimate that through the photograph itself. And so if we draw a storm relative wind vector, which is just a wind vector from the right moving storm motion plot back to the photograph, and then if we draw a horizontal vorticity vector perpendicular and to the left of the photograph, we compare the orientation of these two, and if they're parallel, in this case they are, we have streamwise vorticity. And so streamwise vorticity is concurrent in the low levels of the atmosphere, and if we continue to do that up in the column, very parallel shear vector orientation. So we are expecting a very streamwise environment in a vorticity sense. Going over to Springfield, Illinois, also at 0Z, we see again a strongly sheared environment, but the instability is not quite as robust. Again, this is a little earlier in the life cycle of the event, and at least in the Illinois context. They get hit a little later, and so buoyancy is likely a bit delayed, at least with this observed sounding. So if we look at a RUC proximity sounding for this region, we can see that by 2Z, just 2 hours later, we have destabilized a lot more, and we have now over 1600 joules per kilogram of most unstable CAPE. And now our effective storm low felicity has increased substantially as well, on the order of 430 meters squared per second squared. So a very strongly sheared environment. You can just see the very strong curvature and elongation in the low level photograph. This sounding is also coincident with an F2 tornado that did tear through Springfield, Illinois, and is also characteristic of the six-state supercell. And this supercell tracked all the way from northeastern Oklahoma all the way into Michigan. And so we're going to dive into those details. This is just a skew T in the vicinity of that storm and the parent tornado that was associated with it. Here's the track of that supercell storm, and you can just see the large swath that it took up. And it basically started from that second round and ended in the late night hours the next day. And so it's very long track supercell and very uncharacteristic. Now that we've got an understanding of the environment, now we're going to jump into real-time data here and how the Storm Prediction Center handled the event, and also look at some supplemental radar data. Starting here for the first round in the early morning hours of 12Z, we have an initial mesoscale discussion issued by the SPC here, and they have increasing confidence here for that isolated hail threat that we were annotating for that first round. So the same idea, and we can see here on radar that first bunch of storms there, some little supercells that are starting to initiate across east central Kansas, and this is at 12Z again. And we can see at this time as well, they issue a severe thunderstorm watch, and for increasing confidence in severe thunderstorms in this particular region. And then they also have a supplemental severe weather watch across the Kansas-Missouri border. Going forward about an hour and a half to 1345Z, we can see most of those cells have expanded northeastward into those target areas the SPC outlined, and much of that region now expanding into southeastern Nebraska. Going forward into 15Z, we can see that the storms are now trailing into Kansas City. As those storms approach north central Missouri, around 15Z, we have another severe thunderstorm watch that's issued by the Storm Prediction Center, issued for increasing confidence in those severe thunderstorms. Now it's round two, and this is where we're expecting the more robust round. Not the most robust round, but more than the first round. Here at 1630Z, we have a mesoscale discussion issued here by the Storm Prediction Center, and they have increasing confidence in damaging tornadoes, very large hail, and wind damage. So they have a likely scenario for supercells in this environment, and this precedes a PDS tornado watch that's draped across much of the central United States, east central Kansas, much of central Missouri, stretching into west central Illinois. And if you're not aware what a PDS tornado watch means, it just is issued in special cases where there is a particularly dangerous situation. And that's just when there is increasing confidence in there being strong to violent tornadoes across a large swath of a particular region. So looking at some supplemental radar data, this is 18Z, and notice this blob of convection initiating in south central Kansas and northeastern Oklahoma. This is the sign of our second round starting to initiate with that second impulse aloft. Going forward an hour, we see it grows upscale pretty quickly, and we can see embedded supercells in this cluster across southeastern Kansas become a little more discrete as we get into 20Z, and they encroach the Missouri-Kansas border and continue off to the northeast. I want you to notice the two supercells that are located between Kansas City and Columbia here. These are the ones responsible for the main tornadoes of the second round and were characteristic of the only strong tornadoes in the second round. But also, this is associated with the supercell that tracked through 5 states. Here's a nice video that illustrates the path of this supercell that does take a path through 5 states. And again, beginning in the afternoon hours of that second round, goes straight through portions of central Missouri northeastward, does its toll on Illinois here in Springfield, doing its EF2 damage, and then continues for an extended period of time into the overnight hours, all the way through Illinois into northwestern Indiana, and eventually dissipating in southern Michigan as it gets engulfed from the back. So very, very long track supercell. And again, we can see now by 0Z, as this supercell is still going on in northeastern Missouri, we have the third most robust round starting to initiate here. And we can see that just 1 hour later, a widespread line of supercells from north to south across northwest Missouri, southwestward into southeastern Kansas. And by this time, about 40 minutes later, the SPC issues another PDS tornado watch across an even larger region. And again, issuing a PDS tornado watch for increasing confidence in strong to violent tornadoes. Now to look at some more specific radar data, we're going to jump to GR2 Analyst, and we're going to use the KEX radar and start right where we left off at around 1Z when that third round is starting to get going. Notice all the discrete supercell formations and all the kidney bean and hook echo appendages, but specifically this one down here is looking the most pronounced with that velocity couplet coincident with the rear flank of the storm right in here. Going throughout time, we can see that circulation starts to increase, and we can see that the hook echo appendage becomes a lot more defined, coincident with that velocity couplet. This does end up producing a tornado, rather brief, however, and goes through multiple cycles as well, which is very characteristic of this region, very cyclic tornadic supercells. Going back to 1Z, this was our first target storm we just looked at, but now I want you to pay attention to this cluster of cells just to the southwest of it. Going throughout time, we can see that the structure of those cells becomes a lot more coherent as a supercell structure as it moves into Missouri, and you can see that coincident with a strengthening velocity couplet, a sign of an increasing mesocyclone, and then eventually does produce a weak tornado and is not terribly persistent, but it is a quite classic supercellular look right here. If we go down to the south, where a lot more of these discrete supercells are initiating, again, we see multiple supercells, one, two, three, four different supercells down here in a discrete formation moving eastward into a favorable environment. And as we go throughout time and it approaches the Springfield radar, I want you to pay attention to this storm right in here and its associated velocity couplet. It starts to increase pretty substantially, and we do get a strong tornado out of this one. You can see a very, very defined velocity couplet here. Inbounds here are at around 55 knots, while the outbounds at around 55 knots. And so we have a rotational velocity of about 55 knots, and so a very strong circulation, and that's coincident with a pretty strong supercell moving just south of Springfield. And again, that couplet keeps enhancing. And unfortunately, we don't have dual pole radar during this time period, so we can't look at correlation coefficient, but this is giving us a pretty textbook look. Now I want you to focus on the cell just to the north of that, because that one gets itself going pretty early on as well. Going throughout time, we can see the circulation start to increase pretty substantially, and it starts to become, the forward flank becomes a lot more elongated. Then you see a little shower that starts to merge with its rear flank, and it starts to tighten up that vortex. And so a little bit of a merger, and that rear flank tightens up that vortex. And again, it does produce a brief tornado, a bit far from the radar to tell the exact velocity signature here, but there was a tornado reported, and it did do some damage. Now, when it comes to the strongest tornado of the event in central Missouri, associated with this cell just east of Marshall here, we're sitting at around 240Z, but the unfortunate thing about central Missouri is that it's in a bit of a radar hole, pretty large one at that, and so it's going to be hard to resolve the exact radar features here and what's actually contributing to tornado genesis. But going through the loop one more time, we do get one frame, one singular frame where we see the velocity couplet here. It's very minimal and it's hard to see, and I would never suspect a tornado being on the ground with this sort of signature. Um, that's why reports are very helpful in these sort of circumstances, and in this case, reports did come in with damage, significant damage at that, and there may have been an influence from the cell from behind nudging the rear flank downdraft of this cell and reinforcing the tightening of that vortex, but it's a bit hard to tell with the unresolved radar data here. But this indeed was the strongest tornado of the event. All right, now to do a deep dive on the last storm for this video, and it's going to be that long track supercell that went through 5 states and produced the EF2 tornado across Springfield, Illinois. Here's that robust supercell just to the southwest, and it's making its northeastern track and becomes very organized, elongating its forward flank, and that hook echo appendage being pretty pronounced by this point. We're at about 240Z and a very strong couplet coincident with a hook echo appendage just to the southwestern flank of that supercell, and a very defined and photogenic radar signature overall. So that's going to do for this video. Thank you all for watching. I hope you guys enjoyed. If you have any questions, please let me know down in the comments. But I hope you guys did learn something today and that it did spark your interest in the weather. So again, hope you enjoyed and have a great rest of your day.